Hello and welcome to my next tutorial on KVM, or what are called kernel virtual machine images. Now if you watched the last one, I basically did a video in Windows 8.1 running VirtualBox, installing Ubuntu 14.04 Server Edition. Essentially this is going to be a similar tutorial, but now we're going to be doing this on Linux. So the installation of Ubuntu will look exactly the same as it did on the Windows video, but we will be using a different technology instead of VirtualBox on Linux. So the first thing I want to do is share my desktop with you guys. Okay, now you should see my desktop. This desktop is running what is called Linux Mint version 17, I believe, and this interface is called Linux Mate, or the GUI is called Mate. Basically, I don't really like the Ubuntu default, what they call Unity. I'll actually show you a picture of what Unity looks like here. So Unity is this toolbar on the left here that they eventually switched to. I don't really like this, and I know if you're an experienced Linux user, you know that there's ways to get around this and switch to different desktops, as well as even you're able to use Mate, what is called Mate, on this interface on Ubuntu. But I prefer to just use, if you go to linuxmint.com/download.php, you can come down here and use this Mate version is the one I'm using. And essentially the way I like my desktop is like the old GNOME 2 days, if you've ever used GNOME. I basically want all my icons along the top here, and I also want all my running tasks along the bottom, and I also want minimize, maximize, and close on the right hand side. If you ever used Unity, which is the Ubuntu one here again, most of that is changed. You can actually see when I hover over these icons, they're on the left here. And I know you can customize all this and change this, but for me, Linux Mint out of the box is nice and easy to set up, and there's very little configuration for me to do this setup with how this looks. The other thing that's nice about Linux Mint, it is actually based on Ubuntu Linux. So if you know how Linux distributions work, they're essentially built from a core base system most of the time. So if you've ever heard of Debian, Ubuntu is actually based on Debian, and Linux Mint is actually based on Ubuntu. So they all eventually get some stuff from Debian, which is the underlying operating system for a lot of Linux distributions, and has been around for a long time. If you actually search for Wiki Linux distro, click this first link, scroll down here, you can actually see this massive tree of Linux distributions, and it's very, very comprehensive. And as you can see here, I won't focus on all of them, but you can see Debian started here as the original operating system, and these are all clones of Debian, all these little trees off of it. You can see eventually it's actually almost hard to find Ubuntu, but here's where Ubuntu started, and there's actually all these other distributions just based on Ubuntu. So here's the one I'm using, which is called Linux Mint, is the one I like the most so far. I used to be a big fan of GNOME, GNOME 2, and then they switched to Unity, and I have not really liked that. And I know you can use, there's like Cinnamon, and there's all these new ones, but in the end I like simple as possible, as well as very retro, I would guess you would call it, considering this looks like GNOME 2 almost. Okay, let's start with the KVM stuff, the kernel-based virtual machines. Now, I touched on this on the VirtualBox VirtualBox tutorial too, you need a modern-based CPU. If the CPU does not have virtualization on it, this is not going to work. So the first thing you want to do is make sure you check to make sure your CPU supports virtualization. You can do that by looking on the manufacturer's website. I actually show you how to do that in the other VirtualBox tutorial, and make sure that all checks out. And you enable it in the BIOS for, I believe, Intel chips are the ones that need to be turned on. So make sure you have that turned on, and I'll show you how to check in Linux once we're ready to check that. Okay, so the first thing I'm going to do, I actually have some notes here because I don't remember all these commands all the time, and many times you shouldn't have to either. So many times I'll just create a notepad, save it wherever you want. Make sure you back it up. Use a program like Dropbox, or send it to yourself through email, or even use Google Docs or something in the cloud that will save these commands, so you don't have to look them up every time. So the first thing I want to do is load up a terminal, and in Linux Mint, there's the whole menu system is down at the bottom here, and you can search for terminal, and here's terminal. I actually have it pinned, or whatever they call, to this toolbar up here, and I've made a terminal essentially with a lot bigger text for these videos. Now your terminal may not look the same here. Usually the way it's set up is just going to say the username you're logged into. So mine is thechef17, and my host name, if you remember on the VirtualBox video, during the installation, unless you pick host name, mine is set to System76. I actually run if you Google System76, it's a Linux-based laptop that is all the hardware is supported for Linux. If you're interested in what model I'm using, I believe it's the Gazelle Pro, but anyway, I could maybe talk about that in another video. The first thing we want to do is install the kernel-based virtual machine. So I want to do, and I'll try not to copy-paste commands. It's better to practice typing and make sure you get these commands right, especially as you're new. You don't want to just copy-paste them, and this will actually help you remember them over time too. So let's do sudo apt-get install qemu-kvm libvirt-bin virt-manager virt-viewer, and enter your password, and then just click yes. Now I had some of these packages already installed, so chances are this went a lot faster than your system may have gone. But anyway, it should be, once it's done, you want to now check to see if it sees the Intel or AMD CPU with virtualization. So you want to do kvm-ok. Hit enter. And right now, it'll actually probably tell you during the installation of these packages if your chip supports virtualization or not, I believe. I've seen it where it spits out where it says, hey, you don't have an Intel or AMD chip that supports virtualization. But if you ever come to a server or another machine, once you install these packages, or if someone else installed them, and you need to know if the machine can use virtualization, you want to type in kvm-ok, and you'll say KVM acceleration can be used. And it'll basically say can or cannot be used. There's other ways of checking. For now, this is the easiest way I've seen to do it. Okay, the next thing we want to do is get the Ubuntu ISO again. So we want to go to ubuntu.com. We want to go to server, overview, download. Okay, and now it's going to download. You can actually see I already have this download, so I'm going to cancel this. And the first thing we're going to do now is switch to root. So you do sudo su dash, and since I entered my password before, it's already going to let me switch to root automatically. So there's a directory called, if you go to cd var lib libvirt images, this is where the KVM, the kernel-based virtual manager, stores all the images for the installation. So this is where you want to put all the ISOs for your system, or you already have existing ones, like you can see here. I have a bunch of them already here. ls will basically list out the files on the file system. So you can see here I have Ubuntu 1404 server AMD 64. So in order to, usually you don't have this. So actually let me remove this. So I'm going to do this, and now you'll see that it's gone. Now usually it'll end up in your downloads folder. So let's do cp home, the username that you use to download the that you're logged into on your Linux machine. Go to downloads and then Ubuntu. You can see I have a bunch of different versions here, and so we can do cp home the 17 downloads and then the full file name. And then instead of typing in this giant directory here to where you want it to go, you can just hit dot. And that basically means copy this file to this location that I'm currently in. And now if I do ls, you can see that it's let's do an ls. You can see it's there. Whenever you're on the terminal too, you can always use part of the file name. So if I start typing Ubuntu here and hit tab, it'll complete as much as it can. So it knows that I have a Ubuntu here, as well as, what else do I have? Oh, there's a couple things here. So these actually aren't directories, I'm sorry. So if you do ls Ubuntu like that and then hit tab after you type a U, it'll autocomplete it, since that was the only option. You can do ls win, and when I hit tab, it knows that there's more than one available here, so it actually spits out which ones you may want. So say I want to list the server image one. So that's a little bit about ls if you've never used that. I may make an entire tutorial about ls in the future, but for now, those are the basics. It's basically ls. CD stands for change directory, so we did cd var libvirt images, and the other one was home, the chef, downloads, and I have tons of stuff in here, so I won't actually show that on the tutorial. Okay, so now we can type clear. And let's go back to our normal user here instead of root. And let's come down here and go to what was this under? Actually forget, maybe programming. Nope. Anyway, I usually just type it in here. So there's a virtual manager. And I actually have it pinned up here. So this is my virtual machine manager. And this is the graphical interface for the kernel-based virtual machines. And I'll actually get into a little bit of the command line-based virtual machines after we install Ubuntu. So the first thing you want to do is connect to the local host. Chances are you won't have anything else here, which is fine. So you want to click this new icon. And this should look pretty familiar. You want to do dev01 if you watched the other video. I just did local media, which is ISO. Now if you click browse, this is where the var lib libvirt images folder is looking for these files. So it's like, which ISO do you want? This browse local was not always there. You can now use this button to browse to your home directory or your downloads directory and select the ISO. out of habit, I still copy everything to var lib libvirt images. So it shows up in this list. So let's pick this ISO. You want to do Linux here, and you want to select the version we're running, which is 1404. You want to do next. Here is just like the VirtualBox, we get to pick how much RAM. I did 200, 2048. And I actually give it 2 CPUs here. And the virtual machine, I don't think we were able to select the number of cores it could use. I'm pretty sure you can in VirtualBox, but here it's actually during the installation, and you can always change it later on. You can use as little as 512 megs of RAM, up to, like, I would say 4 gigs is plenty. So I use usually an average of 2 gigs. 2 CPUs is fine. Then I click forward. Now KVM has the same concept of the virtual growing of the disk. So I do 20 gigs here, and I don't allocate the entire disk now. So basically what this is saying is allocate as much as it needs up to 20 gigs. So it won't actually use your entire 20 gigs right away. So that's actually really nice. Okay, let's go next. If you click these advanced here, for now, I don't have to change any of these settings. And if you watch the VirtualBox tutorial, the NAT stuff didn't work as well as we wanted to. So we actually had to change some stuff on the VirtualBox. You'll see later in the tutorial that Linux actually makes the NAT work fine, and we don't actually have to change anything. So let's just leave that alone. Okay, so this should look familiar to you if you watch the VirtualBox. So let's just run through the installation of Ubuntu one more time. And I pick US keyboards, US language, no, English, English. I'm going to go fairly fast through the prompts here. If you need a slower time in between when I'm picking these options, I recommend watching the VirtualBox video, because that's where I kind of explain every aspect of this installation. I'll briefly explain it here, but for the most part, once you do this installation once or twice, you'll know exactly what options you want to pick, and you can kind of fly through it. So here it's auto-detecting IP addresses, and if you know what DHCP is, it'll automatically detect the IP address here. So our host name was dev01. The username, the full name I use is Ubuntu. The username is Ubuntu. I pick a strong password with numbers and letters. I don't recommend encrypting the home directory. I'm in Chicago, so that time zone's fine. Okay, I use guided entire disk. I select the 20 gigs. These are the default file systems for Linux. I just hit yes. So this should all look pretty familiar to the similar to the first video I did on VirtualBox. This is essentially the same setup, but now we're installing Ubuntu Server Edition on top of Linux Mint. Okay, once this is the other thing too with KVM, we had the problem where the mouse gets stuck in the square and you can't get it out. So like right now, I'm moving the mouse a ton, it will not release it until you hit Control-Alt on the left. So if you hit Control-Alt, my mouse will pop back out here, and then if I click inside here, it'll be locked again. So Control-Alt is the key combo. On VirtualBox, it was the right control that unlocked the mouse from the virtual machine window. We don't have a proxy here. If you have a big company and and you're behind a proxy, you'll have to ask your system administrator or someone in IT for that credentials to get through the proxy to get it onto the internet. If you're just doing this at home or on a normal network, you should not have a proxy. Okay, the next thing it's going to ask us for, I believe, is the automatic update stuff. And I recommend don't doing automatic updates. And now we get to pick any software we want to install here. I don't pick any of these. I'll install it. I'll actually install SSH here once we get into the machine. So just hit tab and then hit continue. And the reason I don't recommend automatic updates is I usually update my system pretty regularly, but I do it on my terms. I don't want to be working on a big project and have a package that gets updated that breaks something and I don't know that package got updated. 99% of the time that won't happen, but I've seen where certain services also get automatically restarted, which is one of the last thing you want to be doing. Is if you're running, say, a web server and it's running Apache and it's your only web server connected to the internet, and all of a sudden it runs updates, it's going to restart your web server. Hopefully that's automatic updates you can schedule like in the middle of the night, but at the same time, like if your users are worldwide, you may have traffic on the website and it will restart services automatically. That's one thing I don't like about automatic updates, is it could restart a service without you actually knowing about it. So I run them all manually. You can always script updates, but I always, which means you can run them easily across hundreds of machines, but I always manually do it at off hours when I know traffic on our sites are very low, and we always have multiple servers in order to not have the website go down. So when one machine's updating, then the other one is still accepting traffic. Okay, the next thing here is, do you want to install to the master boot record? I always pick yes. Now, if it's like a database server and it restarts automatically, that's really bad because your application may disconnect to it, and then you're really screwed if you're not monitoring it correctly. All right, let's finish this installation. Now it's going to reboot, and it's going to go straight into the Ubuntu prompt, just like we had on the VirtualBox. So let's log in as Ubuntu, put in our password. Let's do an if config and check what our IP is. So our IP is right here, 192.168.122.33. So if I come over here and let's do this, you can see the ping works fine. So the network translation stuff, because you can actually see here, if config here, scroll all the way up. My IP address is 192.168.143, so this one's definitely using NAT, because this one is, I know this looks similar, but this 122 would have matched here if it was in the same IP range. Okay, so the next thing we want to do is let's install SSH, just like we did. Well, first thing you want to do is run updates on any machine. Let's do that first. So we want to do sudo su dash, and I'm going to run updates a little bit different this time. I'm going to actually switch to root so we don't have to use sudo every time. And I'll actually show you a trick on how to, basically with Linux you're able to put two commands together with the ampersand. So anytime you want to run multiple commands on a Linux system, you can use double and symbols, I guess they call them. So let's do apt-get update, and then you could do and apt-get upgrade. And this time we're even going to pass a command, this parameter -y to the upgrade. Actually, I'm going to put that before. This way, it won't even actually ask us if we want to update the system. With this one command, it'll update, and then upgrade the whole machine with one command without hitting anything else after I press enter. It's actually really nice to have this command memorized, because then this is one of the easiest commands to copy and paste or just type into any machine, and then you just hit enter and you'll get all the updates, and it won't prompt you. So one thing nice about Linux is that all the commands can all be added together with those ampersands, the and symbols, and you can use parameters to say, hey, I don't want the machine to prompt me to install updates, just do it. That -y basically says just do it, finish these updates. Okay, this machine will be patched in a minute. As you can see, it's restarting update or a service here. This app port got stopped, and it'll start it back up a little bit later. So, forewarning, services do get restarted when you're running updates, depending on which services got patched. Okay, in the last video I talked about the only time you need to reboot a Linux server, is when it gets a new kernel. And right here it got the new kernel again. So it's this, you see this generating boot init rd. So we're going to do a reboot here. So it gets the new kernel. Log back in. And now let's install, switch to root. So this should look familiar from the first video. Let's install SSH. And I could have passed it -y there, so I didn't hit Y, but I actually forgot that time. So now let's do an if config. Okay, so our IP is the same here. So now I can do SSH Ubuntu. So this is the virtual machine over here, and this is the local machine here. And now I'm going to SSH into it. So this is like the putty session if you watch the first video. So let's do SSH Ubuntu at 192.168.122.33. And the first time you connect to any of these machines, it's going to make sure this, it's basically saying you have not connected to this machine at all yet. Do you want to accept its key? If you see this and you've already connected to it, you may have some security problems. Maybe I'll make another tutorial on what all this is doing here and how SSH, this fingerprint stuff works. I should actually do that. So let's do yes, because I know this is the first time I'm connecting to this machine, and then enter the password. And just like that, I am now in this virtual machine. The nice thing about this KVM, I can just actually file quit, and let's open another terminal. Let's go into the virtual machine again. See, it didn't prompt me for that fingerprint the second time around. So once you connect once, that fingerprint stuff goes away. So in the first tutorial, I went into Python. I did some real simple print hello world, print Dan Scheffner, print, follow me on Twitter at. So the way you copy and paste in Linux, it's a little bit different than PuTTY. So the first thing you want to do is say we want this command. So we want to select it, and you can right-click and go to copy, and then you can come over here, left-click, and then right-click, paste. Just like any other program. This can't be done in Windows command prompt. They're actually finally fixing this after decades of terrible, terrible copy-paste functionality in terminals. I can't believe it took them this long, but they're finally fixing it. So it's easy to copy and paste in Linux. Just right-click, copy, right-click, paste. And I can hit enter, and that works fine. The keyboard shortcuts for copy and paste on Linux are a little bit different. So if you select this, instead of just hitting Control-C for copy, you hit Control-Shift-C. And then you can come over here and hit Control-Shift-V, and it'll paste it out. So instead of Control-C and Control-V, it's Control-C and Control-Shift-C, Control-Shift-V. So that's how it's super easy to copy-paste on the Linux terminals. You can also use the menu items here if you're more comfortable with that. So let's do this one. So select it, edit, copy. It actually shows you here, Shift, Control-C, Shift, Control-V. So let's do copy there, and then we can do edit, paste. So the terminal works a ton better in Linux than it does in the Windows CMD stuff, if you've ever used it. Okay, so the next thing I want to show you is, and this is just a brief introduction to the KVM stuff. Basically, the way this graphical user interface, I actually closed it out. Let me open it again. Sometimes you may not have this virtual machine manager. Lots of times this KVM stuff here on these notes, so we installed all this stuff, is running on a server that just has a terminal like this. To get out of these Python terminals, just hit Control-D, and we'll go back to this. So let's close this terminal. So say you come to a Ubuntu server or a Debian server, and you think it's running virtual machines. This is how you check for things that are running on this virtual machine without this graphical user interface. So imagine this wasn't here. So the command to connect to what we call a hypervisor, and the hypervisor is basically the technology that is running on top of Linux to emulate these machines. And specifically this one's called the KVM hypervisor, I believe is, and there's a bunch of different hypervisors if you just search Google for that term. And I could actually talk about those later in a different tutorial. But the one we're specifically using here is KVM. But the command we want to check to see which virtual machines are on the system is called virsh. So let's hit virsh. Interesting. And I wonder if I actually have to be... Pretty sure this... Oh, I'm actually in... Okay, this is very good that I actually screwed this up. Now you see down here I'm inside the virtual machine. So this is important to note that it doesn't say System76 here. It says Dev01. So I'm actually inside the virtual machine already here. Now let's close this out and load up a new terminal. I was like, why isn't that working? Let's make this bigger. So now we're on this local system. So that's why hostname is so important. I know that my laptop is called System76, and I know the virtual machine is called Dev01. So immediately I checked the host name when I saw that, hey, this command wasn't installed, and why is that? But now that we're on the System 76 machine, laptop, we can do virsh. And now we're on the virtualization interactive terminal. So you can basically control and install and do everything you want from this interface that you would have done through this virtual machine manager. So say let's see what virtual machines are running. You just type a list. So we see dev01 is running. Let's see if there's more than just dev01 on this machine. Yours might not have any extra, but I know mine has a bunch. So if you do list -- all, you can see, oh, I have dev01 running, and then I have these others that are powered off. Oh, so let's say we want to, say you're a system admin and someone calls you and say, hey, dev01 is screwed up. Can you reboot it? So there's commands you can just do. I actually put them in these notes. So let's just do, I think it's just reboot dev01. And just like that, the dev01 is being rebooted. Now, say you need to get the IP address of dev01. Now this is a little bit more complicated because this is the virtual machine in it. If it's not running SSH, and it may not always be running SSH, hopefully it is, but you may not know the IP address of it. And say you need to get the IP in order to get into the SSH of it. So let's do dom if file dev01. I actually can paste that right here. This will spit out the MAC address of the virtual machine. Now that doesn't help much, but you can easily get the IP address associated with this arp-e command. And this arp-e command is actually a Linux command and not a virsh command. So you got to be careful which commands go with which. If you're confused on which commands are which, if you ever see virsh in the front of it, it's a virsh command. You can also type help here, and you can see all these commands. And there's tons and tons of them. And for example, I did reboot here, and it says right here, reboot the domain. So that's actually one I just ran. So if you are confused if the command is a Linux command or a virsh command, you can look through this list and see. These are all the virsh commands you can use. So we can also use list here. Where's list? I don't actually see it, but I'm sure it's there somewhere. But anyway, this arp command is a Linux command and not a virsh command. So let's load up a new terminal. The great thing about Linux terminal is it supports tabs just like Firefox, just like Chrome. So instead of clicking this icon here, let's say we want another tab, so we can switch between virsh and Linux, the Linux terminal. So in order to load a new tab, just hit Control-Shift-T. And that should be pretty familiar if you've ever used a web browser. It's the same. Actually, it's not the same. I think it's Control-T. Yeah. So terminals use Shift and Control, and like Chrome uses Control-T, and it'll just create new tabs. Same with Linux. You hit Control-Shift-T, and it'll make as many terminals as you need across the top here that you want. So let's close some of these. Okay, now for this arp command. So the arp command is a Linux a Linux tool to give you out IP addresses based on MAC address. So if we just do arp-e, it's going to give us all the IP addresses of all the machines that are associated with this machine. And there's actually quite a few. So we're going to learn a new command called grep. And grep is basically to filter out text from one command to the next. So basically, we want to do arp-e, this pipe, which basically says take the output of this command and send it to this command. And it'll basically say grep the MAC address of the server we want. So our MAC address here, and you can always use tab everywhere in the terminal. So as you can see here, I already forgot the domi, is it file list? Yep. So I didn't really know this command, but I knew it started with dom. So I just said domi tab tab, and I'm like, oh, it's file list. So I know that this, and I can do dev01, and it'll spit out the MAC address. So that's double click. You can double click this, and it'll select the text. Right click, go to copy, and instead of this MAC address here, I'm going to paste it here. So now I can take this arp command, copy it, Control C, come to the terminal, right click, and go to paste. And you can see right away the IP address 192.168.122.1.33. Now we knew this because we connected to the server already, but many times you may come to a server and it's running virtual machines and you may not know the IP address at all. So that's how you get it from so we can easily just copy that and go SSH Ubuntu. Of course, you have to know the username and password, which is a different story and all, because you're not going to be able to just find that through the terminal. The other thing that's nice about these virsh commands, if you do man virsh, it basically says, give me the manual page for this command. So I'm going to introduce you to what are called Linux man pages. So let's do this, and there's unbelievably amount of information about each command, and this goes on probably for a little bit. It tries to be as concise as possible, but as you can imagine, there are tons and tons of commands for everything in virsh. So if you need to read about a certain command, you can always do man, the name of the command. So next thing you can use page up and page down easily. To quit out of a man page, you just hit Q. So let's do man grep. And pretty simple. It says print lines matching patterns. And as you can imagine, there are tons and tons of options for grep. So here, one command that you may were like, oh, I saw him pass -y to apt-get. And why did he do that? What does that do? So if you want to do, let's look up apt-get. So you do man space apt-get. Now sometimes these manuals go on and on and on forever. So in order to search a man page, you hit the /, which is next to the right shift. So it changes at the bottom left, and we want to search for -y. And then you just want to hit enter after you put in -y, and it'll immediately start matching all the patterns here. You can see it came up here, but here is the more direct answer. And as you can see, it says automatically yes to prompts, assume yes, answer to all prompts, and run non-interactively. So that's exactly what we wanted to do during the installation of the packages, was to to skip the prompt. So that's how you use the man pages in Linux. So let's hit Q to get out. I'm going to go back to this. The other nice thing about virtualManager, the graphical user interface one, is it's not only the local machine it can connect to. So if you have multiple virtual machines, like multiple Linux servers, you can actually connect to different ones. You can actually see I have another virtual machine KVM host running on this 10, I believe. So let's enter my password. Maybe this is not set up correctly. Oh, there we go. You can see I'm running a Windows 2000. This is probably a Windows 2012 server on this other machine. So this is the local machine. You can see Devo1 here, but this is a completely different machine, physical machine on my network. And you can see that it's connected to, this is the IP of it, 192.168.1.10 is that physical server I have running somewhere else. The other nice thing is here, you can customize this layout. This is pretty new. Well, new in the last couple of years. They didn't always have this virtual machine manager. So CPU is nice. So actually you can see I can actually make the CPU spike really quickly. Let's open up a new terminal. You can always hit up to see the previous commands you have put in your terminal. So here's the command to connect to the machine. If I enter the right password, you'll get in. Okay, so watch, I can make this. If I do Python, I'm going to do while true. Basically, this is going to just say, as long as true is true, so it's always going to be true, run and just print out my name as fast as possible. And just like that, you'll see the CPU spike like crazy, trying to print to the screen. Now, since this machine has 2 cores, I can actually run this again. Can never seem to get this password right the first time. Now you'll really see that it's 100% used of those 2 cores, and it's completely maxed out on this machine. It's probably even struggling to do the 1 core. So let's stop this. The other nice thing you can do here is you can do view. I think it's view. So the host is this machine, I believe, and the CPU usage is the virtual machine. So you can see here I have an 8-core machine, and it's starting to spin up a lot. And but I'm not using all the cores on the host machine. I'm using the full 2 cores on the virtual machine. The other thing you can do, I believe, is right-click and go to details, and then you get even a better output of what's going on the virtual machine. So this helps for like system administrators, like what is going on with the overall virtual machine. So you can see this is not Devo1. This is my local laptop, and you can see I'm using up to 25% basically. So I'm using 2 cores out of 8. And you can see here I'm using about 2 gigs total of my 16. There's a bunch of other information here you can click through if you're interested. I was looking to see edit, I think it's edit preferences. Nope. I was looking to see there's usually other stats of the virtual machines. Let me see if I can find those details. So here's a little bit more. So I went to Edit, Virtual Machine Details, and I go Virtual Machine, View, Details here. And you can see performance here. So we already have CPU, but now here's memory. Here's it says this stuff's disabled, so you have to actually enable that on a different setting. And eventually, I probably will enable the disk I/O and the network I/O, so you can actually see how much disk I/O and network I/O it's using. Here's another interesting thing. You can actually change how many CPUs it's using. So let's go to 4. Let's save that. And it says it'll only change next time it reboots. So let's close this out. Close. Let's stop this. So to stop a program, just hit Control-C. Hopefully this stops. There it goes. And then Control-D to quit out. Let's exit. Exit. Let's exit all these prompts. And let's, if you right-click here and go to Shutdown Reboot, should be rebooting. I've actually noticed sometimes it does not reboot automatically here. And I don't know why. And it could just be a limitation of the way the virtual machine works. So let's do sudo reboot. Okay. Now let's see if I right-click on this. Okay, virtual machine view details, processors. Now, see, it still says current even though I changed it to 4. So I actually think you need a full shutdown in order to change things here. So let's do Ubuntu. Sudo shutdown -h now. We'll shut down the machine. And I just can't get this password correct. Okay, now this virtual machine is off. Now, if I do open, so now it says 4 here. So let's start it back up. Okay. I don't need this window. Let's actually use the terminal. Let's load Python. While true, colon, enter, tab, print, hello world. So now it's using 1 core out of 4, and it's trying to do that as fast as possible. So let's load it up again. Now it's actually interesting. The CPU usage is almost maxing out on this machine. Which I would have expected it to not do that because I actually don't want to do this too much more because I'm actually trying to stream this at the same time. So one thing you can do inside your virtual machine is check to see how many processors it had. Maybe this still didn't change over to 4. and maybe you can only do it during the, it says 4 here, but I don't think it actually has 4. You can do cat, which basically means print out. Let's actually look at man cat. So it says concatenates files and prints them to the standard input. So don't worry about what concatenate means yet, but prints them out to the standard output, which means basically the terminal. So if you do cat proc cpuinfo and hit enter, this will go through all the processors that are on your machine. So we have a processor ID 0 here, which means 1. Then we have a processor ID 1. So we actually do have all 4 cores for this virtual machine. I wonder if we have to reload this virtual machine thing for it to auto-detect. It's interesting that that graph isn't lower. Up. So this graph is deceiving. I've never actually noticed that. The way I usually monitor CPU usage is a different way. So this is just kind of demoing the virtual machine software. So maybe it is the host preferences. So maybe it is the host CPU and not the CPU usage. I'm not sure what CPU usage is. Maybe that's something else that I used to be able to do. I know I keep going to the same spot because I swear I used to be able to turn these on and off easier through that interface, and maybe I'm just not selecting preferences. Oh, here's disk I/O. So here you do, to turn on the disk I/O stuff, I just missed it in the menu. Edit, connection detail, edit, preferences. And you want to do disk I/O and network I/O. And you can see right here, we're starting to get stats on those. I don't see where I turn these on. But anyway, if you look here, they're correct. And maybe that's better to look at the virtual machine details. So you can see here we're using about 50% here because we're running one thread that's printing hello world as fast as it can, and another thread that's trying to print out follow me on Twitter. You can actually see it hangs a little bit even as fast as it can go. We can actually do a third if you want, and if you guess, it will go to 75%. So this is actually a pretty good stress test for servers if you ever need to know how long they could run at a peak usage. One thing I would recommend even doing is when you buy a brand new server is loading up, once you get Ubuntu on it and run updates, the first thing I do is actually come into the terminal, install SSH, come into the terminal, and peg the CPUs as fast as I can. I usually get the whole machine up to about 75% CPU usage, and I run that actually overnight to see how long, and I also monitor the temperature of that. That's probably for a different tutorial, but this is a good stress test for I You think this would change, but now it's not changing, which is interesting. And maybe it just can't handle much more than printing out to the terminal. If you do calculations, you'll get more CPU usage, I'm sure. So let's do this. Like, let's do x equals 1, and let's do while true. Let's do x equals. Let's do plus. Let's actually do times equals 2, which basically says I'm gonna, every time it runs through this loop, I'm gonna times it by 2 and save it as x. I'm going to do print x. So it's going to start at 2, go to 4, or I'm sorry, it's going to go, and it'll go really fast. And as you can see, it grew so fast. Let's see if we can get the CPU up anymore. And actually, I think it's having a hard time doing the calculations and getting it out to the screen. I wonder if we do. Nope, I can't get the CPU any higher than 48%, which is strange. I wonder if this is actually reporting strange or incorrect data. So I'm going to quit that and actually show you a different way to look at the monitoring of the CPU. So let's load up another terminal and see if this one is any better. So the thing you can type here is top. And top is basically a Linux-based monitoring tool. And you can see all the processes that we're running on this machine. And you can see there's 3 Pythons running here. And the most important number here is basically this right here. And which tells me here, the closer this number is to 100%, the more idle I believe it is. So right now, it's so taxed that it really can't do much more. It's almost that it's nowhere near 100%. So if I move this over here, and let's stop these. Let's see if we just stop 1, if it'll go back. No, it seems like it still only has access to 2 cores, and maybe there's some setting I need to change to make it have access to 4, because it seems like it still only sees 2. So if I stop this, I bet you this will say 50. So it's actually lower than I thought. So that's interesting. So this thread here is only taking up about 25% of 1 core. So maybe that's why. So if you did more and more and more, I bet you we could get this. So maybe the CPU stuff is working, and we're just pushing the machine too hard with this print statement. So this is 1 thread here, and you can see that it's not near, it's not even half. So this one is taking, I have a calculator here, so if you do 100 minus 83, so this is using about 17%. If I control C out of this, it'll go back to 100. Or close to it. So this is what you want to see when your machines are idle or in good working, unless something's just going crazy. So like, let's load up this calculation program one more time. See what it does. So you can see this while true here is a lot harder on the system than just printing to the screen. right now it's using 100 minus 25, or 100 minus 75, which is 25. So you can see it's using a lot more CPU here. So actually we can do, let's see if we can get this machine fully up to 75% CPU. I'm not sure. So let's see what. So right there, we're up to 50%. Let's see if we can do this one. So right there, we're at 75% CPU used. Now let's see what the virtual machine actually says. Yeah, I don't trust these numbers here anymore. Because 37% is certainly not correct. You can see that we're using up 75% of the CPU. So I actually wouldn't trust these numbers. I bet you there's either a bug here in this software, or there's something else going on and it's just not reporting it correctly. I always trust Top. Top is by far the best program to monitor your Linux systems. So you can see we're using 75% basically. Now, and you can see we're running Python 3 different times. Now if I load up another tab and look at the System76 top, this is going to be higher because I actually have more cores on the on this system than I do on the virtual machine. So this machine has 8 cores, and 3 are basically being fully maxed out with 3 are being fully maxed out with the virtual machine, and I'm running tons of other stuff. As you can see here, I'm using Chrome to stream this stuff too. I hope the presentation is still running okay, because I am using my machine a ton as well. So as you can see, I'm basically using 4 cores 100% of the time here. Another thing to check to see how many cores you have is you can do cat proc CPU. So this should look familiar. So you can hit enter, but then we can just do, let's see, hey, we want to know how many processors there are. How many times does it say processor? So you can just do that. You can do 1, 2, 3, 4, 5, 6, 7, 8. There's 8 processors on this machine. And we could even pipe that command to one more command. So let's do this, and you do wc -l. So this is basically saying, let's spit out all this text here. Let's filter out the word processor. This is what we get here. And let's count how many times it says the word processor. Just like that, you have an 8-core CPU. So we can actually copy this, and let's go back to the virtual machine. Let's stop these. Make sure we connect it to the virtual machine. Paste this in. You can see it has 4. So these graphs are nice, but I don't think they're working very well. I always trust Top. And part of the reason, too, it could be because of the virtualization, the way virtualization reports processor load, too. So just be careful with how you monitor your Linux boxes, too. I always recommend using Top, and you'll see that Top usually is pretty close to reporting the correct usage. Okay, let me switch. Okay, thanks for watching this video. I know it was probably a lot longer than I actually expected, but I think it was a good introduction to installing Ubuntu Linux using KVM. The next tutorial I actually make is about something called LXC, which are Linux-based containers that are even faster than going through the whole installation of Ubuntu each time. LXC containers are super quick and are nice to use. There's actually one last thing I can show you here if you want. Let's switch back. Another great thing about these virtual machines, let's stop this one, shut down, see if it actually works. Okay, let's clone this one. So say you need, this one's all set up and it's doing stuff that you want, but hey, I need another version of it. Let's just clone it. So you right click, go to clone, and it'll just say all these details are fine, and just hit clone. And now it's actually going to clone the virtual machine for you. Now there's one caveat to this. When you clone the virtual machine, it unfortunately shares the same MAC address as the previous Devil one, and this may take a minute to clone. But once it's done, you got to think of too that it's actually copying the file system here too, so this may take a second. But one thing that's unique to this machine is the MAC address. So let's start this one up. And cloning is really nice to get a base system installed, and then you're able to. So let's log in here. See if they actually fixed this. I think maybe they actually fixed this. This IP address used to not be here, and it was super aggravating. You actually had to do something special. Let me see if they finally fixed this. And the reason why is because you don't want each machine to have its own MAC address. I mean, you do want each machine to have its own MAC address. So now this is the clone and this is the original. Now you can see the IP addresses both came up, but this one's now different. So if you do SSH into this one, it's going to tell you it's never connected to it, even though you have with 33. So let's do no here, and let's see what it says for 33. So since it shares the same keys, the fingerprint thing, it's fine. It actually, that's one bad thing about these machines is right now they're sharing the same fingerprint for each machine. And that's actually one thing in a future tutorial I'll show you how all this SSH stuff works with the keys and how you can remote into a machine without actually putting in a password every time. But that's how you can actually clone these virtual machines. If you ever have a point where it doesn't have an IP address here, you want to go to etc udev. I think it's, let me see here. Yeah, rules. And there'll be a file here. Yeah, I actually don't see the rules here. But there used to be a file called like 70.rules, and what you want to do is comment out the MAC address of of the machine. Let's see what this file directory. So they actually fixed this, so you can ignore that. But if you ever don't have a file, an IP address, when you clone a virtual machine, usually this is where you got to fix it. You come into this etc udev rules, and I bet you if you search Google for this, it comes up. Let me see here. I actually had a script. Yeah. Actually, it's on this local machine. So here's an example of like these MAC addresses. You want to look for eth0, which would be this one, and you want to put a £sign in front of these two in front of this line. It's just a single line. And then you want to reboot the virtual machine, and it'll re-get the IP address of the machine. So this is the file you're looking for, etc-udev rules 70.persistent.net rules. If you search Google for this, I bet you it comes up with a bunch of hits about, yeah. See right here, clone list them, and all of a sudden it didn't have an IP. So they finally fixed this. I set up a Ubuntu system and configured it properly, defining eth0, blah, blah, blah. When I booted up the system the first time, all was good. But then my initial research found that it didn't have the IP address. So that's how you fix it if it doesn't have an IP address. They finally fixed that here. That must have been a kernel fix, because it was like that for a very, very long time. But anyway, you can see how cool the clone feature is. You can actually use virsh to clone too, so I'll actually show you that real quick too. So let's open up this virsh. Let's do stop devo1. Is it stop? Maybe it's not stop. Oh, shutdown. You can actually see it stopped back here. And now you can do clone, I believe. Let me Google this real quick. Virsh clone. So there's actually a separate command for cloning on the terminal. Does it have... Does it have clone here? No. So there's actually separate commands for virsh. So this one's called virt-clone. And I want to actually see how to use this command. It's been a long time since I've used KVM, but I'll actually show you how to. So it's just -o is the original guest. So that's devo1 and the name we want down here. So we can do clone o devo1 and our new server. And if you use the right command, path must be specified to clone. Interesting. So this command's even changed over time too. There's an auto clone. So it actually wants where I want to put the virtual machine. Ugh. It's always fun when commands change. What's interesting too is that, and maybe this is because I'm not running it as root, you put these files in this varlib libvirt images, and you don't run this virtual machine as sudo, and you don't run virsh as sudo, but I can't look in this directory, which is a little bit confusing. I don't really like that. I used to run this all as root, and maybe that's what I recommend doing in production systems, because the only reason I used this username was because it had a desktop environment. Let's see if this works. So yeah, so list all still prints everything here. So even though I'm under a different user, original devo1 name new server. And there was like an auto clone. Let's try that. Where was that? Okay. So here's a bunch of examples too. If you scroll all the way down to the bottom of man pages, a lot of times they'll have a bunch of examples. So basically it's just like, where do you want to put the new file? And let's do, whoops, what was the parameter? I already forgot it. -- file. So I want to do -- file var lib libvirt images new server.img. Let's see if this finally works. And I think it's working. It actually gives you a nice progress bar, even though it was at 100% already. It's basically copying what the original server was. So this is a way to clone a server on the command line. So now if you come back to let's close this and close all these out because I think I'm done. Let's go to the virt-manager. And as you can see here, new server. So this is a third one we even cloned off of these other two. You got to make sure that the virtual machine is not running in order to clone it, I believe. Will it let you clone now when it's running? That'd be awesome. Oh no, see, it won't let you clone it when it's running. Some virtual machines, virtual machine services may let you clone while it's running. They'll like do a freeze in the file system, but KVM apparently will not let you do that. So if you load up this is our new clone server that we just cloned off the command line. And this is all the same username and password stuff. This probably is the same IP34. So I bet you if we started this one, this will get 35. Because it's using DHCP to get these yep, 35. And I'll actually talk about static IPs and all different types of information about networking later on. So these don't change all the time on you. Because that's one thing that's annoying too. If you're creating virtual machines for testing, IP addresses are pretty much, whatever you want. You can use DHCP. But if you are creating virtual machines for, say, other developers or other things that are in production, you want to make sure you're using a static IP address, which means this number will not change. And you can assign it a number that won't change every time. Basically, I think I'm done here. Let me switch back to okay, I know this video went probably even longer than the first time I switched over, but I think we're finally done. I showed you KVM. I showed you how to install Ubuntu again for the second time. So if you're on Windows or any Linux operating system, you should be able to install Ubuntu 14.04 using KVM. I got into the next time I will show you a different way that's even faster than KVM that we've been using more and more these days called LXC, which are Linux-based containers. I showed you a couple commands, ifconfig pulls up the IP address of the server. I showed you virsh, which is basically the terminal to manage KVM. I showed you virt-manager. You can always load virt-manager from the command line too. So if you just type in virt-manager, you don't always need to load it through the graphical user interface or the GUI. So that's another thing you can do. What else did I talk about? I talked about how to detect the number of CPUs using cat proc CPU. I talked about grep, on how you can grep out the text inside of any Linux command. So if you just use the pipe and then if you just use the pipe and then pipe it to grep and the text you want to filter. I talked about how to count the lines on the terminal. The command to do that is wc space -l. The other command I talked about was how to run updates again, of course. So apt is the underlying package manager for Debian, Ubuntu, and Linux Mint. I'll be actually talking about in a future video on how to create your own mirror of packages that you use. So you don't actually have to always go out to the internet. And that's one of the great things too about Linux, is that we can actually store all the updates to a local system inside your network. So you don't have to first download, of course, is gigantic, but after that you can get updates from this mirror almost instantly. Not that Linuxes are slow to get the packages in the first place, but if you've ever managed like an entire company of Ubuntu desktop machines, there are lots and lots of packages that need to be updated, and going out to the internet for each machine is not a great solution. So I talked about apt-get. I talked the last command we looked at too was called man, M-A-N. So those are the manual pages. You can search those with the / next to the shift and type in what you want and hit enter. To scroll through all those, after you press enter, you just hit N to go to the next. To quit out of the man page, you hit Q. That's pretty much it for what I think I talked about. Oh, I talked about how to check for the CPU that it has the virtualization enabled. You can do kvm-ok. And the last thing I talked about was how to get the IP address of an existing virtual machine that you may come to already running on a virtual server using the domiflist. I guess that'll get the MAC address, and then you can use arp-e and then pipe that to grep and the MAC address, and it'll spit out the IP address. And I will put all these commands in the notes of this this video, and hopefully this wasn't too long. I'll try to make them a little bit shorter next time, but I think this was a great review and an introduction to Linux and how to get Ubuntu running in virtual machines. Thanks for watching, and please subscribe and follow me on Twitter. Talk to you guys soon.